Hi, this is George Woodbury from the College of the Sequoias in Visalia, California. And in this video I'm going to go over how to simplify rational expressions and solve rational equations. The first problem we have here, find the values for which the rational expression is undefined. Keep in mind that a rational expression is undefined for any values that cause the denominator to equal 0. So here we're going to be looking for values that cause the denominator to equal 0. Set the denominator equal to 0. Since this is quadratic, we'll factor. Set each factor equal to 0 and solve. So the two values for which this rational expression is undefined are 3 and 6. To simplify a rational expression, we want to factor the numerator and denominator and look to see if we can divide out any common factors. Both of these trinomials factor. The numerator is x plus 3 times x plus 4. The denominator will be x minus 9 times x plus 4. And we can divide out the common factor of x plus 4 in the numerator and denominator. And that's going to leave us with x plus 3 over x minus 9. If I'm going too fast for you, keep in mind you can always pause this recording and do the work yourself, then turn it back on and check your work. Another problem where we're simplifying a rational expression, we'll begin by factoring the numerator and denominator completely. Notice that 25 minus x squared, that difference of squares factors to be 5 plus x times 5 minus x. And we notice that x minus 5 and 5 minus x are opposites of each other. When we divide any number by its opposite, it's equal to negative 1. So when we divide out these opposite factors, we're left with a negative 1 as a factor in the numerator. And keep in mind, we can always move that negative 1 out to the front of the fraction. So what remains standing is x minus 8 in the numerator, 5 plus x in the denominator, with a negative sign out in front of that. To multiply two rational expressions, it's very similar to simplifying a single one. We want to factor each numerator and denominator completely, then look for factors that are common to a numerator and a denominator. The first fraction, two trinomials. The second fraction, we have a trinomial and a difference of squares. So we'll factor all four first. And then we start looking for common factors. I think a safe way is to go right across the numerator. Do I have an x minus 8 numerator and denominator? Yes, I do, so I can divide that out. X plus 3 I don't have. X plus 2 I do, so I'll divide that out. And x plus 11 I don't. So the remaining factors will multiply together, but leave them in factored form. This simplifies to be x plus 3 times x plus 11 all over x minus 9 times x plus 8. To divide rational expressions, just like dividing numerical fractions, we want to replace the divisor by its reciprocal. And in doing that, we can change division to multiplication. So the first step here is to rewrite this as the first fraction times the reciprocal of the second. Now that we have a multiplication problem, we can go ahead and factor numerators and denominators. Keep in mind that x plus 6 here won't factor because it's a linear term and there are no common factors. The two trinomials in the first fraction factor, and then I have a difference of squares, which will factor to be x plus 7 and x minus 7. And again, we're looking for common factors, x plus 7, numerator and denominator. We also have an x plus 6. And that's going to leave us with x minus 1 on the top over x minus 5 times x minus 7. To add two rational expressions that have the same denominator, we can simply add straight across the numerator. We'll combine the like terms 6x and 7x to be 13x. Now we have a single rational expression which we can factor the numerator and denominator for, and then see if we can divide out any common factors. X squared plus 13x plus 36 factors to be x plus 4 times x plus 9. In the denominator, this factors to be x plus 9 times x minus 7. Notice we have a common factor of x plus 9 in the numerator and denominator, and when we divide that out, we're left with x plus 4 times x minus 7. Okay, a subtraction problem with the same denominator. The thing we want to be careful with here is that this subtraction sign has to be applied to each term in the numerator. So when we combine the two numerators into a single numerator, we'll have 9x plus 4 minus 5x plus 16. We have two like terms in the numerator. 9x minus 5x is 4x, and 4 plus 16 is 20. Now it's time to see if we can factor and cancel. In the numerator, we have a common factor of 4 that we can factor out. The denominator is a trinomial, so we can factor that as well. And I have a common factor of x plus 5 in the numerator and denominator. That's going to leave me with the fraction 4 over x plus 10. In this example, we're trying to add two fractions that have opposite denominators. We can replace the second denominator by its opposite, provided that we replace the operation by its opposite. In other words, the second denominator can become x squared minus 4 if we change the sign from an addition sign to a subtraction sign. Again, the idea here is that we're making two opposite replacements that cancel each other out. Okay. So again, addition to subtraction, replace the second denominator by its opposite. Now that we have a subtraction problem, again, remember we need to distribute that minus sign through. And combining like terms in the numerator, we keep the common denominator. Combining like terms in the numerator, x squared minus 3x minus 10 will factor to be x minus 5 and x plus 2. The denominator is a difference of squares, and we have a common factor of x plus 2, leaving us with the rational expression x minus 5 over x minus 2. In this example, we have two rational expressions that have completely different denominators. So, as I mentioned in class, when in doubt, factor. We'll factor the two denominators, and we need to build these fractions up so they have the same denominator. Notice that the first fraction does not have a factor x plus 4, so we'll multiply both the numerator and the denominator by x plus 4. In a similar fashion, the second fraction is missing the factor x plus 5, so we'll multiply top and bottom by x plus 5. So at this point, our two fractions have the same three factors in their denominator: x plus 3, x plus 5, and x plus 4. So we can combine these two fractions into a single fraction with that denominator. To simplify this, we're going to multiply 7 by x plus 4 and negative 4 times x plus 5. I'll do that on the next screen. 7 times x plus 4 is 7x plus 28. Distributing the negative 4 will give me negative 4x minus 20. The next step is to combine like terms in the numerator, then we'll check to see if we can factor. When we combine like terms, the numerator becomes 3x plus 8. Now 3x plus 8 does not factor, it's linear, and there is no common factor. Since we don't have a factor of 3x plus 8 in the denominator, this rational expression is as simplified as it can be. Similar problem here, except it's an addition problem, and we have a binomial in the numerator. That will indicate that we will most likely have to use FOIL multiplication to come up with the first numerator. As I mentioned before, begin by factoring the denominators. What's missing in the first denominator? It's missing an x plus 2. So I'm going to multiply that in, numerator and denominator. The second fraction is missing x plus 5. So again, I'll multiply that in the numerator and denominator. Keep in mind that when we multiply by the same expression in the numerator and denominator, we're really multiplying by 1, which does not change the fraction at all. So we've got a little multiplication to do to clean this up. We'll do that on the next screen. X plus 6 times x plus 2, we're going to multiply using a FOIL type multiplication, and then we'll distribute the 4. X plus 6 times x plus 2 is x squared plus 8x plus 12. 4 times x plus 5 is 4x plus 20. Now we're ready to combine like terms. Notice that in these problems the denominator is already factored. We do need to factor the numerator. This trinomial will factor to be x plus 4 and x plus 8. And we have a common factor of x plus 4, leaving us with the result x plus 8 over x plus 5 times x plus 2. This is an example of a complex fraction, and to simplify a complex fraction, we want to begin by finding the common denominator for all the fractions, which here will be x squared. To simplify this, we'll multiply the common denominator by the numerator and denominator, and here I've shown I've distributed it through to each term in the numerator and denominator. X squared times 1 is just x squared. In the second product, x squared and x reduce to simply be x. X times 7 will be 7x. For the third product, x squared and x squared completely cancel out, leaving us with just 12. In a similar fashion, the denominator will be x squared plus 4x minus 32. Time to factor and cancel if we can. Here's the factored form of the numerator and denominator. Divide out the common x minus 4, and we're left with x minus 3 over x plus 8. Notice that even though this problem involved a common denominator, we used it to get rid of the denominators that we had. We did not build up these fractions. The same approach holds true when we're trying to solve rational equations. Again, here I have an equation I'm trying to solve. I begin with the common denominator. Now I have 3 denominators to worry about, x squared, x, and x squared. In this case, the common denominator is x squared. So I want to go through and multiply each term on both sides of the equation by x squared. X squared times 1 is just x squared. X squared divided by x squared is 1. Those cancel out. X squared with an x in the denominator reduces to simply be an x, and x times 3 is 3x. And finally, x squared divided by x squared is 1. That leaves me with 10. So my new equation, x squared minus 18 equals 3x plus 10. When we have an equation with an x squared, quadratic equation, we want to collect all the terms on one side and set it equal to 0. So to move the 3x to the left side, I'm going to subtract 3x on both sides. And I'm going to write that directly after the x squared so that my trinomial will be in descending order. I also have to move the 10. I can do that by subtracting 10 from both sides. And that gives me the new equation, x squared minus 3x minus 28 equals 0. Now it's time to factor and solve. This trinomial will factor to be x plus 4 times x minus 7. Since that product is equal to 0, I know that one of the factors has to be 0. So I separate this into 2 separate linear equations, which I solve. The 2 solutions, I'm going to subtract 4 in the first equation and add 7 in the second. So x equals negative 4 or x equals 7, and that's my solution set. Keep in mind that when we solve rational equations, we must check to be sure that our solution is not an extraneous solution. In other words, it can't make a denominator equal to 0. If you recall in this problem, all of our denominators were either x squared or x, and the only value that would cause those denominators to equal 0 would be 0 itself. Since neither solution is 0, both of our solutions are valid solutions. Another rational equation. Before I can figure out the common denominator, I'm going to have to factor both of these denominators. Once that's done, I can determine my common denominator. A good rule of thumb is to begin by copying down the first denominator, x minus 2 times x plus 1. Now I look to the second denominator. Are there any factors here that did not show up in the first one? And I do have one more. It's x minus 5, so I'll write that down. And that is my common denominator. Before I move on, it's a good idea to label the restrictions in this problem. X cannot be equal to 2, -1, or +5. If I get a solution that's one of those three values, I have to throw that out as an extraneous solution. Okay? So I'm going to multiply both sides of this equation by the common denominator, x minus 2, x plus 1, x minus 5. Same thing on the right hand side, x minus 2, x plus 1, x minus 5. And I'm going to divide out common factors. The idea again here is to clear the fractions, x minus 2 and x plus 1, leaving me with just x minus 5 times x plus 4 on the left. On the right side, divide out the x minus 5 and the x plus 1, and that just leaves me with 6 times x minus 2. To solve this equation, I'm going to have to do a little multiplication now. I'm going to FOIL out the left side, and I get x squared minus x minus 20. On the right side, I distribute the 6 to get 6x minus 12. Because I have a quadratic equation, again, an equation whose highest degree is 2, I need to collect all the terms on the left side where that x squared already is. I can do that by subtracting 6x from both sides and at the same time adding 12. That will leave me with 0 on the right hand side of the equation and a trinomial on the left hand side. To finish solving, I'm going to factor the trinomial. And after I set each factor equal to 0, I get two potential solutions. X equals 8, x equals -1. I'm going to have to omit that second solution because -1 was in my list of restricted values. So my only solution to this equation is x equals 8. On to everybody's favorite, the application problems. This first one involves the sum of the reciprocal of a number and 7/12 we're told is 3/4. We need to find the number. So I'm going to let x represent the number. The reciprocal of the number then is 1 over x. So I'm told that the sum of 1 over x and 7/12 is 3/4. So that's my equation. The common denominator here will be 12x because the common denominator for the constants 12 and 4, the LCM of those two numbers is 12, and I'm also going to need an x to cancel out this x in the denominator. Multiply both sides by 12x. In the first multiplication, the x's cancel, leaving me with 12. In the second multiplication, divide out the 12s. That leaves me with x times 7, which is 7x. On the right-hand side, 4 goes into 12 3 times, and 3 times 3 is 9, so I have 9x on the right-hand side. I need to move the 7x over to the right. Because this is a linear equation, I want to collect all the variable terms on one side, and I finish by dividing both sides by 2. Here, my number is 6. Moving on, the last two word problems we're going to work through are examples of work rate problems. For work rate problems, we need to know the amount of time each person works alone. We'll use that to determine the work rate for each person, how quickly they're working. We're also going to need to have an expression for the time that it takes the two people working together. And we can multiply the rate by the time they work together to come up with a portion of the job completed by each person. So our two people are Jerry and Bill. And we know that Jerry can mow a lawn in 40 minutes while it takes Bill 50 minutes. So we'll write down 40 for Jerry and 50 for Bill. The work rate is the reciprocal of the time. So 1/40th for Jerry, that means that he can mow 1/40th of the lawn in 1 minute. Bill's work rate will be 1/50. How long does it take them together? Well, if we knew that, this problem would be done. We'll choose a variable for that. I'm going to use t for time. Pretty common in algebra to use t to represent the unknown whenever it's a time. To come up with the portion completed, we multiply the rate times the time. So 1/40th times t is t over 40. For Bill, 1/50th times t is t over 50. And I know that those two expressions have to add up to equal 1, which, remember, is the equivalent of 100%, or one complete lawn that's been mowed. So let's move on to the equation. We'll solve it together. There's the equation again. The common denominator for 40 and 50 is 200. That's the lowest common denominator. Now, you could use a bigger one, but keep in mind there's going to be more reducing at the end if you do that. 200 divided by 40 is 5. So that leaves me with 5t. 200 divided by 50 is 4. That leaves me with 4t. And 200 times 1 obviously is 200. Combine like terms. 5t plus 4t is 9t. And we want to go ahead and divide both sides by 9. And so we get 200 over 9. It's customary to convert this answer to a mixed number. 200 over 9 as a mixed number is 22 and 2/9. So if they work together, we know that it would take 22 and 2/9 minutes. On to the last problem. Another work rate problem, but this time we'll be given the time it takes them together, and we'll be trying to find the time it takes each person working alone. So without all the headings, I'm going to write down the two names, Earl and John. How long does it take Earl by himself? Well, we don't know that, but we do know that it takes him 6 hours less time than John takes. So if we let John be t, Earl will be t minus 6. So that's the time alone. For the work rate, we take the reciprocal of that. 1 over t minus 6 for Earl, 1 over t for John. For the time together, in this problem, we're given that value. They can do this in 4 hours, so the time together will be 4. And again, if we multiply the rate times the time together, we'll get the portion of the job completed by each person. 1 over t minus 6 times 4 is 4 over t minus 6. If you're not sure where that came from, remember that we can treat the 4 as if it's 4 over 1. I'm not sure why I wrote t here. That's a 4. 1 over t times 4 for John is 4 over t. And again, the portion completed by each person has to add up to equal 1. All right, there's the equation. The common denominator here is t times t minus 6. And you want to make sure that your common denominator, or the denominator you choose, will cancel each of the original denominators. So we're going to multiply both sides by t times t minus 6. The first fraction, the t minus 6's divide out. In the second, the t's divide out. And we're going to be left with this equation. To solve, we've got a couple multiplications to do. 4 and t will both be distributed. We've got a pair of like terms on the left. Combine those to be 8t. And we can move those to the right, where t squared is, by subtracting 8t from both sides. At the same time, we want to move the constant, so we can do that by adding 24 to produce this equation. Now we want to go ahead and factor. And if we set each factor equal to 0, we're going to get the two solutions, t equals 2, t equals 12. It looks like these are both valid solutions, but let's go back to the table and check that out. In this table, I've listed the time, the variable expression for time for John and Earl. I think I have those backwards, actually. This was Earl, and this was John. That shows you if you prepare too early, sometimes you get in trouble. If t is 2, that would take John 2 hours. But 2 minus 6 for Earl would be negative 4 hours. And you can't do any sort of work in negative time without a time machine of some sort. So t equals 2 is impossible in this situation. If t is 12, that means it takes John 12 hours. And Earl would be 12 minus 6, or 6 hours. So it would take Earl 6 hours to take care of this task. Well, I know that was really fast, and I hope that you found it helpful. If you have any questions or comments, follow up on any problem, there's a couple of things you can do. Either leave me a comment on the video here on YouTube, or you can reach me through the contact page on my website, georgewoodbury.com. Thanks, and we'll see you soon.